times. Yes. Before carbon mugs. Those were the days. Kids today with their carbon mugs. Anyway, Rick Smalley was really cool. He spoke, and he'd have to sit down. He'd talk for a few minutes, and he'd have to sit down. He died of cancer just a few weeks after I interviewed him. But he was the first guy that I met that just said it so succinctly. The key to the future is not to do less. Next Monday is, just a couple days from now, is Earth Day. I grew up with Earth Day. I went to the first Earth Day at the National Mall on my bicycle, which I walked to a flagpole. And everybody in those days wanted you to do less. Wanted you to drive less. I rode my bike. They wanted you to use less clean water. So in hippie tradition, everybody should wear dirty clothes. And then, if possible, just don't even eat. Just not only use less food, just don't even eat, because humans are bad. Humans don't belong in the ecosystem. Humans, just get rid of them. But that part, that non-eating part, just turned out to be very unpopular. Rick Smalley was the first guy I met that just said it like this. Not that we need to do less. We need to find ways to do more with less. And that is the key to the future, my friends. That is where you are going to change the world. Yes! The whole world. So if you told my grandfather, let alone my father, that we could plant sunflower seeds in a field of soybeans within 7 centimeters using signals to a tractor beamed to it from outer space, he would think you were at least drunk. And yet we are doing that today. This is me on my roof. It's a picture of me on my roof in Southern California. I have 4 kilowatts of solar. I have a Solitude dome, which is like a Fresnel lens, like in these lights here. So when sunlight comes into it, even when the sun's low in the sky, it's directed down the tube. It's much, much more efficient than a conventional skylight. I still go in the room there and try to turn the light on. In 7 years, I still get fooled. It's so bright in there. And then in the foreground, I have a solar hot water system. It makes hot water out of sunlight. Now, these systems all exist today. There's nothing extraordinary about these. If you go to Beijing, on the roof of every apartment building is a solar hot water heater. And they put those solar hot water heaters up there because the heat is free. Not because there are a bunch of hippies trying to live off the grid. Right? So the heat comes in, it warms this refrigerant, or I guess it's a heatant, and it boils, goes to the top of the tube, gives up its heat to this scuba tanky looking thing, and dribbles back down, all without moving parts. And this is, by the way, is technology entirely derivative of the space program. Without the space program, we in general would not have heat pipes like this on the roof of every apartment building in the world's most populous nation.
It's called counter-current circulation.
Thank you.
Oh, all right.
Someone's smart.
I know what you're saying, but I'm going with hot water. So, in the United States, we have an enormous amount of wind. We have enough wind just in South and North Dakota to run North America 5 times over. And you'll notice along the eastern seaboard, we have a tremendous amount of wind. These are all wind turbines in New York State. And we could power the whole country with wind. The problem is getting the energy from the wind turbines distributed all over the country. And there are people who don't like wind turbines because they think it ruins the view. There's nothing like a smokestack, to make things.
Yeah.
You probably know people who have these extraordinary houses with fabulous views of the Sound or the ocean. And everybody sits around all summer until what happens? Till a ship goes by where something's moving. Wow, a ship, cool. All right, well, these move all the time. So, it's not all bad. You guys are going to be confronted with what seem like crazy ideas to address climate change. I am of a mind now that there's so much carbon dioxide and so much tradition of burning fossil fuels among humans, the 7 billion plus of us, that we really aren't going to be able to change things just by curtailing our carbon output. The world's going to keep getting warmer for a long time. As they say, even after you take the roast out of the oven, it cooks for a while, because the heat on the outside works its way to the inside. So you guys, especially, are going to have to make decisions as voters and taxpayers, and I hope, as scientists and engineers.
That's right.
I am an engineer, yes. Although, I'm human, I'm an engineer. No, there's engineers here, I take it. Yeah. When I went to school, it was almost all men in engineering. And you could tell, you could recognize them right away at a party, because the pants. Hey, you're an engineer. Yeah. Can you fix the blender? Because the party's. Yeah, sure. Yeah, I'll tell you what. Take the plug and hold it in the wall firmly. Put the blender under some cold running water.
Oh, man.
It's only funny if you're scientifically literate. Anyway, you guys are going to come across this crazy idea. So I'll give you some examples. Here's, we're going to plant fields that reflect sunlight into space. It's going to be fabulous. We're going to breed special plants that reflect sunlight into space. What are we going to eat? Okay, wait, I got it. We're going to make artificial trees. And they're going to take carbon dioxide out of the air, chemically. It's going to be fantastic. Okay, well, why don't we use real trees? It's brilliant. Real trees. Wow. So what you got to do is get people to stop cutting down trees as fast as they're cutting them down right now, which is an international relations very difficult problem. Okay, guy. We're going to have ships that take iron fertilizer out into the ocean and fertilize the sea, grow plankton. They're going to take carbon dioxide out of the air and sink to the bottom. It's fantastic. So you're going to turn the entire ocean into a layer of pond scum. Okay, I got it. Wait. We're going to make ships. We're going to make ships that produce clouds. They're going to pump clouds from the sea surface up into the sky. So you're going to make ships that do that better than the sun. Wow. And they're going to be powered by diesel fuel? How's this going to work? All right, okay, wait. I got it. We're going to have airplanes, and they're going to fly around and put sulfur dioxide into the air, just like volcanoes.
No.
They make sulfur dioxide, and when volcanoes are up, they reflect sunlight into space. So we'll just do it on a global scale. That's great. We're going to have acid rain everywhere. We are going to have reflectors in space. It's going to be great. Nothing will ever go wrong with them, and they will be so cheap. No, wait, okay, that's probably not a safe programming right now. So, none of these ideas is probably the idea. Okay, they're all a little crazy. But it's going to take sort of big picture thinking to address this problem. Now, people come to me with a lot of ideas as the science guy. And I got to say, of all these ideas, one of them is maybe so crazy it just might work. This is the reservoir behind Hoover Dam, and every year we lose a tremendous amount of water billions of gallons of water to evaporation. So if there were a way to reduce the evaporation, you would have more water downstream, more water for everybody, and presumably that ecosystem downstream would be a lot healthier. It would certainly be a lot cheaper. It would actually lower the cost of hydroelectric power and so on. So this guy who is, and this is coming from me, who is kind of an odd duck, has come across this idea, Russell cites, that these guys were looking at the ocean with spacecraft. And they noticed that when a storm goes through the, first of all, when there's clouds over the ocean, it reflects a lot of light into space. But when storms come through, there's white caps on the sea surface, and they reflect a lot of light into space. But even after the storm has passed, the sea surface continues to reflect a little bit of extra light because it has what they call undershine. There are tiny bubbles dissolved in the ocean, and they reflect light into space. And when I say tiny, we're talking about microns, millionths of a meter. The nanotubes are billionths of a meter. The microbubbles are millionths of a meter. And you have to have, if you have two test tubes, you have to kind of have them side by side to even tell the difference. It can be so subtle. But with just a 1% increase in these bubbles, you would reflect enough light into space to actually cool the Earth off. So it's an idea that needs to be examined, in my opinion. So maybe we would have a worldwide bubbleator task force, and the United Nations Bubble Council would keep track of the bubblation. Because there are about 10,000 huge ships, commercial ships at sea at any one time, enormous cargo ships. And maybe we would encourage them through a tax structure or something to have a bubbleator on board, and a certain amount of the ship's power or energy would be used for making these bubbles, and then we could cool the world off. Or maybe we'd make ships that make the bubbles and drive them around next to the Arctic ice sheet, so that the edge of the sheet doesn't get as warm, and it stays there a lot longer and reflects a lot more light into space. It is an idea so crazy, it just might work. But I admit, who knows what it would do to ocean ecosystems? Who knows if it's possible to create these bubbles? Or who knows if the whole idea is not really that good or kind of a hoax? But it's the kind of thinking that I admire, because it's thinking on a global scale to address climate change. There it is again. Let's try it forward. Oh, yeah, still. Soon, you got the idea. Oh, look, it's still reflecting. Oh, there's the ice sheet. So, we can get all the energy we want with wind and solar. My watch is solar powered. You never wonder. And the solar panels in this watch are about 10% efficient. What if the solar panels were 20% efficient, like on spacecraft? Or 30, or 40, or 50, or 80% efficient, using carbon nanotubes as quantum dots to capture photons and shoot one electron. It would change the world. And then we have these turbines. Now, I drive a Nissan Leaf, an electric vehicle.
Oh, we found out what car it
It's commercially available. And so, just like you know how many toilets are going to flush at halftime, you know where the cars are parked. Cars are parked at the shopping mall, cars are parked downtown, cars are parked in garages at night. So you could take the energy from wind and solar and store it in everybody's car. Blah!
Yeah.
But it would, yes. But the problem with batteries right now, any type, is they get hot. The real limitation of my car and the Tesla cars and other electric cars that have been developed over the years is the batteries. But people have been looking into what are called liquid metal batteries. This is where you let them get hot on purpose. Enormous things where you have molten magnesium on top, a layer of molten table salt, And then sunk to the bottom is a layer of antimony or antimony, the one next to tin on the periodic table. And then you just pump all the energy and electricity you want in there, they get hot and they stay hot, and that's cool. So then in every big building like this, we have these things in the basement. They look like semi-tractor trailer containers. And it would be in Manhattan, there would be these things underneath everything. And so we'd pump energy into them all day and take energy out of it all night. There I say it. Change the world. So we need these innovations. Then we need this smart grid that moves the electricity around automatically, the same way your cell phone hands you from one cell to another as you travel down the road. And then we send the electricity around the country and the world through carbon nanotube fibers. As Rick Smalley said, it's as though the electron goes to sleep at one end of the tube, has a dream, wakes up at the other end with hardly any electrical resistance, almost a superconductor. And furthermore, when they get warm, they don't sag and thin the way regular power lines do. They tighten up. It would change the world. When there was a fire on Brook Place in Baltimore, Maryland, where my mother grew up, the fire truck was pulled by horses. When my grandfather went into World War I, he put a gas mask on himself and a gas mask on his horse. That was the state of the art. That was all they had. That's how they conducted business, fire putting out in war. But 20 years later, by the time that thing became World War II, nobody did anything like that with horses. Nobody who was serious used horses. Everything changed in just 20 years. And those people didn't even have the internet. Yeah, what did they do all day? Everything changed in just 20 years with an advance in technology. When I was a kid, I went to the beach and I looked through a telescope at Saturn. And when you see Saturn through a telescope, I claim it changes you. Now, this telescope is on the Cassini spacecraft almost 6 years ago. Cassini's still out there. And it took this picture of Saturn through the rings of Saturn. The sun's in the background. And you can see the shadow of the rings on the planet. I mean, it's an extraordinary, it's a beautiful picture. I hope it gives you pause for thought. But wait, there's more. It's not just a picture of Saturn. It's a picture of the Earth. The Earth is right there. That's it. That dot is the whole Earth. Everything you've ever known is on that dot. If we go up there, a couple 100,000 kilometers, take the same shot, that's it. That's the Earth. Now, if you think about it, as my old professor Carl Sagan would say, there's no cavalry coming over the hill to save us from ourselves. I mean, this is it. This is where we take our stand. This is it. This is everybody who's ever lived. Every tadpole, every fish, every snake, every dandelion, every oak tree, every supreme commander, every peasant, every slave, every couple in love, everybody has conducted his or her entire life on that pale blue dot. When I was a kid, after looking at Saturn, I'm standing on the beach in Delaware, and I'm beginning to feel insignificant. Mrs. Cochran, my third grade teacher, told us that there are more stars in the sky than grains of sand on the beach. And I remember thinking, Mrs. Cochran, really? Have you ever been to a beach? Really? It's a lot of sand. Okay? You look that way and that way, 1,500 nautical miles, there's nothing but sand and sand. And you look behind you and there's sand. The tide goes out and there's sand. You shuffle your feet and there's sand. You scoop up more sand. Sand, sand, sand. I mean, I wouldn't have expressed it this way exactly. But Mrs. Cochran, are you high? There can't possibly be that many stars, but apparently there are at least that many stars. So I'm standing there thinking, well, really, I'm no different from the sand. I mean, if you get out here and look back, it's grains of sand and it's built. I mean, what? These are little specks and these are another speck. And then the Earth, really, in the cosmos, in the scheme of things, it's just another speck. And it's orbiting the sun, completely unremarkable star. Nothing special about the sun. I'm a speck, standing on a bunch of little specks, on a big speck, orbiting a speck, with a bunch of other specks, in the middle of specklessness. I suck!
Untrue.
And when I realized that I could understand it,
And then I realized
I could use my brain, which is only this big. In the case of my old boss's brain. But with your brain, you can understand this. With your brain, you can know your place in the cosmos, your place in space. With your brain, you can reason and predict the future. With your brain, you can use the process of science to make things and solve problems. And with your brains, my friends, you will be able to, dare I say it, change the world! Thank you all. If you have time, I'd like to answer some of your